In this lesson, we are going to talk about comparing key features of quadratic functions in all different forms. So let's talk about some of the main key features we're going to focus on here. First, we have the roots or the zeros, which are also your x-intercepts. So this is where a quadratic crosses the x-axis. So if you're looking at a picture of a quadratic, your zeros are going to be the points, sometimes a point, sometimes 2 points, sometimes it doesn't cross at all, but it's a place where it crosses the x-axis. So in this case, we have 2 of them, and so we would have 2 roots. We would just write the values of those x coordinates. Now, we also have, when we're talking about quadratics, maximums and minimums. So if the function opens up or it has a positive x squared, you're going to have a minimum. And that is because here we have another picture that's opening up. It's smiling because that a value, that x squared value, is positive. Okay? And the reason why this is a minimum is because if you look at your vertex down here, our vertex, that is the lowest possible point on this graph. There is nothing below that vertex, and so the vertex is a minimum. Okay? Remember, we're looking at the vertex when we're talking about a maximum or a minimum. Now, on the opposite side of that, if it opens down, or if there's a negative in front of that x squared, it's going to be a maximum. But for the same reason, if I create my quadratic and I look at where my vertex is, now my vertex is the highest point. It is the maximum height of that quadratic. So again, we're focused on that vertex and deciding whether or not the max or min is the vertex. Now, something super important, I'm going to highlight it here for you. When we're talking about the value of the max or the min, you only want to use the y value of that coordinate. We don't care how far off left to right from 0 that max or min is, but we do care about how far above or how far below 0 that maximum or minimum is. And that's the value that we're going to be comparing when we're comparing maximums and minimums, is that y value. Okay, super important. All right, so let's take a look. We are also going to be talking about the different ways that you can find some of these features, specifically the 4 different methods that you are going to talk about, or you have talked about, I'm sorry, in Unit 7. Solving algebraically, I believe that was lesson 1, where we're just using our inverse operations. We usually do that when there's no middle term, so when you're missing your b value, or b is 0. And when you do that, you can easily find the roots because you're solving for what is x. We also have factoring, and this is a super easy way to give the zeros or the roots. So factored form is when you are going to get answers that look something like x plus 2 and x plus 3, probably equal to 0. And then you can easily get your roots from that. That was back, I believe, in lesson or Unit 5, which I think was in first semester algebra. But it's just another way that you can, again, easily find those zeros and roots. We also have the quadratic formula. This will work for any type of quadratic function. And this also is an easy way, again, to find your zeros. Okay, the quadratic formula gives you the zeros. That's what you're solving for. But also when it's in standard form, you can easily get the y-intercept. Your y-intercept is your c value when it's in standard form. Okay, so it's not necessarily a feature of the quadratic formula. It's just a feature of standard form. And then we also have completing the square. I only use completing the square when b is even, because if b is odd, you're trying to take half of something and then square it. If b is odd, it's really hard to take half and square it when you have a fraction. But completing the square is an easy way to get the vertex. And you can also, if you want to continue going, you can also go and find the zeros and roots. So completing the square is awesome for finding pretty much all your key features. It just only works really nicely when b is even. For finding a vertex, you can always complete the square if b is even and put it into vertex form. And when something is in vertex form, remember vertex form is x minus h squared plus k. And so when it's in that form, you can take your h and k values, and that gives you your vertex. Okay? If it's not in vertex form or you can't complete the square to put it in vertex form, you can also use the formula x equals negative b over 2a. That's for when it's in standard form. You take your b value, make it negative, put it over 2a, and that'll give you the x coordinate, and then you plug it back in to find your y coordinate. So we'll talk about that in a few minutes. And then finding a y-intercept. Just remember when you're finding a y-intercept that you can always plug in 0 for x and simplify, because a y-intercept of anything is where that line crosses the y-axis. And so what is your x value at that point right there? It's always going to equal 0. No matter where you are on this line, x will always be 0. Okay? So you always just plug in 0 and simplify no matter what. That's how you find a y-intercept. And just remember a little trick that if a function happens to be in standard form, then you can use your c value to find your y-intercept, because your c value is your y-intercept. All right, so let's take all of that. You can refer back to those if you printed out your handout. But let's use that and go figure out example 1. So example 1 is asking us to determine if each of the graphs has a maximum or minimum and find the value. Now remember, when we're talking about the value, we only want the y-coordinate, because the y-coordinate is going to be the one that gives us our height. That's how I think about it. It's how far off of the x-axis is that, or how far away from 0 is our max or min. So let's look here. Remember, we always want to look for the vertex. That's the key feature that we're looking for here. So think about what point for this graph over here, at what point is our vertex? Well, it's this point right here, which happens to be negative 1, 2, 3, 4, and positive 6. It looks like negative 4 and positive 6. That is our vertex. Now, think about, is this vertex at the top or at the bottom of our function? Is it the highest point or the lowest point? In this case, it is at the top of our function, is the highest, and so that is why this is going to be our maximum. So I'm going to say it's a max and that it equals. Remember, which value do we want to take? The y-coordinate. So which one of these, negative 4 or positive 6, is my y-coordinate? It would be the 6. So our max is going to equal 6. Now if you think back, we did a lesson on key features. The max or min always comes from the y-coordinate. What key feature comes from the x-coordinate? It's your axis of symmetry. That's that point that goes straight through and everything is reflected over it, and that would be the line x equals 4. Not what this question is asking for, just a little review. Let's look at the next one. So let's take a look at our second graph. Where is the vertex? In this example, our vertex is actually right there at the origin. It's the point 0, 0. So next question, is this a max or a min? Is this vertex at the bottom or top of our graph? It is at the bottom, so does that make this a max or a min? It is a min. It is the lowest point, so that is why it is a minimum. There's nothing below it. It is the minimum height of this graph. And so which one would be the value here? It's 0. It's always your y-coordinate. Remember, it's always our y-coordinate, so it would be 0. So our minimum is 0. Awesome. So now in example 2, I want to know which function has the greater minimum. Now remember, what key feature are we looking for if we're looking for a minimum? We're looking for a vertex. So we have to figure out what is the vertex from each of these functions. Now the beautiful thing about the two functions they give us here is that both of these are in vertex form already. So let's start with f of x. What is the vertex for f of x? So you have to remember that we take the inside and it lies to you. The formula actually says x minus h, and I just want the h value. So that means I don't need this negative. So we're taking the opposite of what sign we see here. Okay? So here I have negative h, but the vertex is actually just h. See how they're opposites? So same thing here. I see a positive 3, I'm going to take the opposite and say negative 3. But then on the outside, it tells the truth. Okay? Lies and then tells the truth. So on the outside, I already have a negative 4, and I'm going to leave it negative 4. Now, the next question you have to ask yourself is this opening up or is this opening down? There is no negative out in front, which means this opens up, so it is a minimum. So this minimum, which they kind of already told us because we're looking for a greater minimum, okay? This minimum, would it equal -3 or -4? Remember, we're always looking for the y coordinate, so this would be -4. So now let's go look at g of x. What is the vertex for g of x? Remember, lies tells the truth. So that -5 becomes a +5, but the 2 is telling the truth, and it stays a +2. Again, we know that this opens up because this is positive out here in front, so it's going to open up, which means my vertex is at the bottom, which means this is a minimum. And what is the value of the minimum? It's 2. So then our question was, which one is the greater minimum? So which one is greater, 2 or 4? 2, sorry, it's a -4, so 2 is greater than -4, which means that g of x has a greater minimum than f of x. So g of x has the greater minimum. That's all it was asking for. Let's go look at example 3. So examples 3, 4, and 5 are all asking what key feature can easily be obtained from the quadratic form below. When we say easily be obtained, I know that I could find any key feature that I want, but they're asking what can we find basically just by looking at this. Okay? So first thing you want to do is figure out which form is this. Well, this is actually standard form, ax squared plus bx plus c equals 0. That's your standard form. And if you look back at your resources that I typed up for you, you should remember that when it's in standard form, our c value is something special that I can just look at and know that that's my key feature. Okay, if you go back and look, it's going to tell you that your c value is your y-intercept. So in this case, our y-intercept is going to equal a -7. So at the point 0, -7, we know that our quadratic is going to cross. That is the key feature that can easily be obtained. Yes, I know I could go find my vertex using the form x equals -b/2a, or I could, b is odd here, but you could technically complete the square, get the vertex and the roots. I can find the roots using the quadratic formula. I know I could find any of the key features I need to, but easily be obtained means just look at it and know. So just by looking at this, I know that the y-intercept is going to be -7 because this is standard form. Okay? Example 4, again, we have that easily be obtained, that key feature that we can easily see without doing any work. So first thing, let's see which form this is in. Well, this is in that x minus h squared plus k. Do you remember which form that is? That's vertex form. So what key feature do you think we can get from this? We can get the vertex. And what is the vertex? Remember, lies tells the truth. So that -9 is lying, it's actually a +9, but that 3 is telling the truth. So just by looking at this, I didn't have to do any work. I know that my vertex is +9 and +3. Example 5. What key feature can easily be obtained? Awesome. So this one, hopefully you remember which form this is. But this is factored form. These are two binomials multiplying, and so this is factored form. And up there in your resources, I do have for you to study that factored form means we can easily get the roots. What are some other names for the roots? X-intercepts, solutions, or zeros. All of those mean the same thing. I'm going to put zeros on here also because they are most commonly used. Roots and zeros are most commonly used to describe the x-intercepts. Okay, so just by looking at this, one of the most common mistakes is that people take both of these and just say that my roots and zeros equal -4 and +7. But you have to remember, they're in parentheses, so they're lying. Okay? This -4 is actually a +4, and then our +7 is actually a -7. Remember, these are two actual separate points. They are -4, 0. That's why they're the zeros. And it's also, I'm sorry, that's +4. Whew, +4, 0, and -7, 0. Okay, those are two separate points. So please, 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 please do not write them as +4, -7. That's a no-no. Okay, remember we're looking for two separate points. They're two separate zeros. And this all comes from the fact that because these equal 0, either x minus 4 has to equal 0 or x plus 7 equals 0, and then you solve those. So we would add 4 over, so x equals 4. We would minus 7 over, so x equals -7. And so that's how we get that our roots or our zeros are 4 and -7. Again, two separate points. And because this is in factored form, you don't really have to, as long as you know that they're in the parentheses and they're lying, you can easily see that they are the zeros of +4 and -7 because you know that they're lying on the inside, so you just take the opposite signs. And so that's what we mean by easily be obtained. You don't have to do all the work. It's already factored for you, so you just have to change those signs and you have the zeros. So when it's in factored form, and I know there's a test question on this, when it's in factored form, you're looking for your x-intercepts or your roots or your zeros, and you're just taking those different signs. Cool, so last thing, you get a lot of questions that are going to ask you about what is the y-intercept. Okay, so what is the y-intercept? So take a look at what form it's in. Remember, you can always plug in that x equals 0. However, we know that this is what form? It's standard form, right? And so when it's in standard form, we can easily find the y-intercept by pulling which value? It's the c value. Which one of these is the c value? The -7. So our y-intercept is -7. Or if it's asking for the point, of course it would be 0, -7, because x equals 0. Okay, so 0, -7 would be our y-intercept. Okay, y-intercept is -7. So make sure you read your question as to how they want the answer. So standard form, no work to be done. Awesome. But sometimes it's in vertex form and they're asking you for the y-intercept still. So this is where that x equals 0 really comes in handy. And it's not that hard. It's a lot of calculator work. We're just going to take out the x, put in the 0, -9 squared plus 3. So then 0 minus 9 squared is -9. -9 squared is a +81. Be careful of that because it means -9 times -9, and a negative is a positive, plus 3. So my y-intercept is actually 84. Now, I know that that feels weird because a lot of people want to just pull out that +3. But as you can see, when you actually do the work, it comes out to be something very, very different. You actually get the point 0.84. So it's just something to be very mindful of. Make sure that you're double checking yourself. Even if you need to go back here and double check. You know, if you plug in 0 for x here and here, what's 0 squared? 0. What's 3 times 0? 0. What's 0 minus 7? -7. So it doesn't hurt to go back and try that. Okay, I think we've covered everything. Awesome. So make sure you've got some notes. Go back and watch the video again if you need to. And go ahead and get started on your assignment.